Hello and welcome to the Pythonic Web3 series. My name is Miguel and I'm your host to show you the Python side of Web3 development. So don't go anywhere. Grab a drink, make sure you like and subscribe. Let's get into the snake pit. The first thing we'll talk about is how to make a smart contract. We all know that Solidity is kind of TypeScript or JavaScript-like language. So there is an alternative for Python and it's called Vyper. So we can go to their website or to their documentation website. It's docs.vyperlang.org and find out a little bit about Vyper. And what they intend to do, from what I understand from the language until now, because I'm also learning the language as I'm speaking to you guys, is that they intend to have a very secure and simple language. So they grab Python, which is kind of a nice choice. So we can check their principles and goals, which are security, simplicity, and auditability. So if the language is simple, it makes a better auditability. And because of this, Vyper provides the following features: bounds and overflow checking, same as Solidity, support for signed integers and fixed points, nothing special here, decidability. It is possible to compute precise upper bounds for the gas consumption of any Vyper function call. This is very interesting and we will need to check how it's done. Strong typing, nice. Small and understandable compiler code. Yeah, sure. Limited support for pure functions. Anything marked as constant is not allowed to change the state. Yeah, that makes sense. I think it's the same in Solidity. When you have pure and view functions, you are not allowed to change the state. Following the principles and goals, Vyper does not provide the following features. So I'm guessing that this is contrasting with Solidity. Modifiers. Okay, so they don't allow modifiers. Class inheritance. Okay, we will need to see how to overcome this, because inheritance is very an interesting approach to do a lot of stuff. Inline assembly, I kind of agree. If the language is optimized enough, you won't need assembly at all. Function overloading, why not? I don't care. Operator overloading, this also shouldn't exist in smart contracts. Recursive calling, okay. Infinite length loops and binary fixed point. They're removing fixed point. Oh, decimal fixed point is better. Okay, so this is because of roundups, I guess. Exactly, leading to okay. So Vyper does not strive to be 100% replacement for everything that can be done in Solidity, of course, because if they're saying that Solidity is not safe enough, they will have to do things in another way. It will be deliberately forbid things or make things harder. That kind of makes sense. Let's take a quick look at the rest of it. Structure of the contract. So we have pragmas, the same as in Solidity. Optimization mode, the same as in Solidity. EVM version, we can select the EVM version. State variables are the variables of the contract for storage. And this is the declaration, and this is how we access the variable. Functions, of course we have to have functions. Events, which are kind of nice to have, interfaces, and I guess we will need to really see how these interfaces work, because if they are removing a lot of features that we have in Solidity, they will have a lot of problems to implement stuff in an easy way. So I think it will be interesting to see how these interfaces work. And structs, we don't have anything else here. We also have the types, so Boolean, unsigned integers, and we have the operators here, of course. We are not going to check all of this at this point. Decimals, addresses, M-byte fixed size arrays, okay, and byte arrays and strings. Oh, this is interesting. This is the bytes, so byte array, okay, and string array. This is how we declare a string. Wow, it's a bit different from Python. Well, I guess this is not Python, but, and enumerates. What else do we have here? Fixed size lists. Okay, this is the way we saw like the string, I guess. It's the same way. Dynamic arrays. Okay, so but the dynamic array, but this seems to be the size. Oh, probably the upper bound integer where type can be the value reference, except mappings. Okay, we cannot have arrays of mappings. Okay, and that's cool. I don't think that's used that much. And struct, okay, mappings, which is the equivalent of a dictionary in Python, I guess. We will have to dig into this. And the initial values are also 0, the same as in Solidity. Type conversions, yeah, we don't care about this at all. Let's try to make a new contract and let's see how it goes. Okay, so the first thing that I did is to install the Vyper plugin. So what you need to do is to type Vyper, and it comes deactivated, so you just need to activate this plugin, and this icon shows up here. It pops up so that you can build your contracts. Now let's create a workspace. Let's make a blank one because I don't like to delete stuff here. Vyper hello, which will be our first contract. Okay, so we just call it hello. Let's make a new directory called contracts and put a new file in here called hello.vy. Vy is the extension for the Vyper contracts. Okay, so let's pray that I know how to code this, and we are going to define a function here called hello. And this function will just return hello to you guys. Sounds nice, easy enough. Let's see what comes out of the compiler. Yeah, it's complaining. I never coded a contract here, so let's see what it's missing around here. The visibility must be set. External or internal contract. It's external because I want to access this from the outside. We don't say anything about the storage accessibility. Let's say that, well, this should be a pure, I guess. Maybe it's pure. Let's see. Compile. No, still missing. Function does not return any values in the contract. Yes, I'm returning a value here, a string. Ah, right. What is it, this string? Was it like this? 100. 20 is enough. Yeah, 20 is enough. Next try. Whoa, it's done. I built the contract just like this. 4 lines. Okay, let's deploy. It's deployed. Wow. Hello. Yeah, it is. And hello to you guys. It's working. Wow, this is easy. We don't have to do anything else. We have a smart contract, guys. Okay. So this is our first smart contract. It's easy enough to deploy this. And it's easy enough to code. So what we need to do is to say the accessibility, which we are saying that it's external so that we can access from the outside. Otherwise, I don't think this button would even show up. And I'm saying that it's pure. Let me remove this to see if anything goes wrong with this. Because I'm saying that it's pure because it's not computing anything. It's not using the storage and it's not changing the storage. So it should be pure. And let's see how to deploy. Let me remove this one so that I don't mess up. We do have the allow. It's not payable, but it doesn't do anything. So we don't have errors, but it's not doing anything. It seems to be acting like a property. Okay, but it's pure, so I don't care about this right now. Let's compile it, put it there again, deploy, and hello to you guys. Okay, so this is our first smart contract. I hope it was fun for you. Don't forget to like and subscribe. And if you have any questions, put your questions in the video comments. And you can also reach us in our Telegram, of course. And I'll see you on the next one. Hello and welcome to the Web3